12 hours after this cruise ship sailed out of an Alaskan fjord, the mountain beside it collapsed. The impact drove water 1,580 feet up the opposite wall, higher than the roof of One World Trade Center. No camera captured it, no warning was issued, and when the mountain fell, not a single ship was nearby. That was not prediction. That was timing. On the evening of August 9, 2025, passengers aboard the Hansa Explorer were photographing South Sawyer Glacier. They were deep inside Tracy Arm, a narrow fjord 80 miles southeast of Juneau, where cliffs rise almost vertically from dark water. The scene looks perfectly still, but the slope that would collapse the next morning is already inside the frame. At 5:26, more than 64 million cubic meters of rock broke loose. It plunged into the fjord beside the glacier. The first wave raced away at more than 150 miles per hour. On the opposite side, its momentum drove water up the mountainside to an elevation of 1,580 feet. The wave itself was not that tall. That figure is run up, the highest point water reached on land. It was still the second highest tsunami run-up ever documented, and no one had seen it happen. But the wave had recorded itself on the landscape.
3 days later, scientists saw a hard boundary across the opposite wall. Below it, soil and vegetation had been torn away. Above it, the mountainside remained green. Satellite images revealed what was missing. Seismometers captured the moment the slope failed.
Tide gauges detected the disturbance as far away as Juneau. Together, those clues reconstructed a disaster, with no eyewitness at its center, where the rock began and how high the water climbed. Then the seismic record revealed something more disturbing. The mountain had not begun failing at 5:26. South Sawyer Glacier had been retreating for years. In just the 2 months before the collapse, its front pulled back by more than 1/3 of a mile. Scientists still do not fully understand the mechanics. But at Tracy Arm, the retreat exposed the base of a steep, fractured mountainside. Then came rapid calving and heavy rain, driving water into cracks and increasing pressure inside the rock. By early August, the slope was no longer quiet. It began producing tiny earthquakes. Not one or two. Thousands. For several days, the tremors grew more frequent and powerful. Roughly an hour before collapse, separate pulses merged into a continuous seismic hum. The mountain was broadcasting a countdown. Scientists recognized the pattern only afterward. The United States had no landslide monitoring system at this scale to turn those signals into an alert. Researchers say those signs could have justified a rising alert at least a day before failure. In the final hours, the tremors could have supported an urgent warning to keep vessels out. The warning signs existed. The warning did not. The tsunami raced down Tracy Arm. More than 30 miles away, kayakers near the fjord's mouth woke to water flowing past their tent. The surge carried off a kayak and much of their gear. At Juneau, the disturbance measured only 14 inches. But inside Tracy Arm, water kept moving for more than a day, as if the fjord had become a bathtub that would not settle. No one was killed, no one was reported injured, and no major structure was destroyed. NOAA says the early morning timing likely reduced the consequences. This danger is not unique to one mountain. Retreating glaciers lie below steep coastal slopes across Alaska and other Arctic regions. Boats enter those fjords for the same ice and cliffs that help create the hazard. The disaster did not begin when rock hit water. It began days earlier, in rain, retreat, and tremors too small for a passenger to notice, but not too small for instruments to record. On August 9th, the Hansa Explorer sailed beneath a slope approaching failure. It left because the visit was over, not because anyone told it to run. 12 hours later, the mountain fell, with no ship nearby. That is the difference between a warning and luck. Next time, The clock may not be as kind,